The next in our series of gates is the OR gate. Again, like the previous gate, it has two inputs and a single output. Let's check out the truth table of this gate. It states that when the input is 0 and 0, the output is 0. When the input is 1 and 0, then the output is 1. And when the input is 0 and 1, the output is also 1. Finally, when both inputs are 1, the output is 1. Let's convert this into a schematic diagram. As before, we need two transistors as they are two inputs, two control switches, an LED and the battery. Finally, three protection resistors. Let's connect the battery and see what the result is when both switches are set to 0 or off. Current flows through R1, and since SW1 is off, the transistor TR1 remains off. It also travels through R2 to SW2, which is also off, and TR2 also remains off. Current continues to flow through R3, but since both transistors are off, no circuit can be made and the LED remains off. Therefore, when the input is 0 and 0, the output is 0. Let's reset the circuit and switch SW1 on. Current flows through R1 and through SW1, switching TR1 on. Current continues through R2 to SW2, which is set as off. Current then flows through R3 to the collector of both TR1 and TR2. As TR1 is on, the circuit can be completed through this transistor and the LED turns on. Therefore, when the input is 1 and 0, the output is 1. Now we shall open SW1 and close SW2. This time TR1 remains off, but TR2 is turned on. Current flows through R3 to the collectors of both TR1 and TR2, and since TR2 is on, a complete circuit can be made and the LED is turned on. So if the input is 0 and 1, the output is 1. Finally, when both SW1 and SW2 is turned on, the current can now flow through both transistors, turning them both on. When the current flows through R3, a complete circuit can be made through either transistor and the LED is turned on. Therefore, if the input is 1 and 1, the output is 1.